Welcome our next video, binomial theorem part 2. We start with the problem number of terms containing integral power of x in x to the power half plus 1 by x to the power 1 by 3 whole to the power 100 is. Options are 12, 16, 17, 19 and 21. The question is that this is a binomial, index is 100, so it has 101 terms. In that terms, 101 terms, how many of them contain integral power of x? You see, first one is x to the power half to the power 100, so x to the power 50. It is integral, it contains integral power. But second term will contain x to the power 49 by 2, 199 by 2 into 1 by x to the power 1 by 3 with some other coefficients. But you see, it is not an integer. Power of x is not an integer. So this way we have to find how many of them contains integral power of x. Just now I told you that first term contains integral power of integral power of x, first term. Now power of first term is 1 by 2. One is 1 by 2 and other is 1 by 3. You see, LCM of denominators of this and that, 2 and 3 is 6. So it is very clear that from first term, after 6 terms, they will contain integral power of x. So there are 101 terms and first term contains this. So 100 divided by 6, that's 6. 16. So 16 terms plus first term, that is, there are 17 terms which contains integral power of x. So this is our answer. This. So for the second problem. If PR denote the product of all coefficients of 1 plus x to the power r. PR denotes the product of all coefficients of this. Then to find the value of p n plus 1 by pn. Options is n to the power n by factorial n plus 1. Second one is n plus 1 to the power n by n plus 1 factorial, then n to the power n plus 1 to the power n by factorial n, and last one is n plus 2 to the power n by factorial of n plus 1. These are the options. আচ্ছা, let us see what is the problem. If this is a binomial, it has r plus 1 terms. So product of these r plus 1 coefficient is denoted here by PR. That is RC0 RC into RC1 into RC2 up to RCR. This product is denoted by PR. Then we have to find the value of P n plus 1 by Pn. So here Pn plus 1 means when the index is n plus 1. So first term is first coefficient n plus 1 C0, then n plus 1 C2. We denote it. Okay. So this is equal to n plus 1 is n plus 1 C0 into n plus 1 C1 into n plus 2 C2 up to n plus 1. Sorry. This is n plus 1. N plus 1 C n plus 1 by this is Pn plus 1. N plus 1 means power is n plus 1. Now divided by Pn, in that case, this is n. So it is equal to nc0, nc1, nc2 up to ncn. It has n plus 1 terms, n plus 1. This is corresponding to first term, second term, and so on. Now, except that in numerator there are n plus 2 terms. In the denominator there are n plus 1 terms. So, except that term, it is only type this divided by that, this divided by that, this divided by that. General term is n plus 1 CR by NCR of that type. This by that, it is for corresponding to R is equal to 0. For R is equal to 1, this by that is equal to this divided by that, and so on. So I simplify it. This is equal to factorial of n plus 1 by factorial R into factorial of n minus R plus 1. This by that, this is equal to that. Whole divided by NCR, it is factorial n in numerator, n minus 1 factorial into factorial R. So they together they cancel. This and that together is n plus 1. This by that, this is just one more than that. N minus R plus 1 is one more than that. So this is equal to n minus R plus 1. So Pn plus 1 by Pn is equal to this by that. This by that, this can be obtained by putting R is equal to 0 over there. N plus 1 C0, N C0, this by that. So we have to put R is equal to 0 over there. If this is equal to n plus 1 by n plus 1 into. Second one, we have to put R is equal to 1, this by that. So R is equal to 1 means n plus 1 by R is equal to 1, cancel, so it is n. Next term is n plus 1 by n minus 1. This way, last term, to get our last term, it must be equal to n plus 1 by putting R is equal to n over there, 1. So it is equal to, there are how many factors are there? There are n factors. So n plus 1 everywhere in the numerator, so this to the power n by 1, 2, 3 up to n plus 1. N plus 1 factorial. So our answer is this one. No, actually this they together they cancels and it is 1. So there are altogether n plus 1 factors were there. So 1, 2, 3 up to n. Now this is the picture. So n plus 1 to the power n, because there are n factors now after cancelling that, and it is 1, 2, 3 up to n. So factorial n. So answer is this, not that. Next, our next problem. The coefficient of x to the power 20 in x plus 2 to the power n plus x plus 2 to the power n minus 1 into x plus 1 plus x plus 2 to the power n minus 2 into x plus 1 whole square up to last term is x plus 1 to the power x plus 1 to the power n. So in that series we have to find x coefficient of x to the power 20. And one more thing given, that n is greater than 20. So this must contain x to the power 20. This must contain x to the power 20, and every term must contain x to the power 20. So we have to collect one by one. It is not possible. Then I take from there x plus 2 to the power n common. Then it is equal to 1. Then x plus 1 by x plus 2 plus, from there x plus 1 by x plus 2 whole square, and last term is x plus 1 by x plus 2 whole to the power n. Here we get one GP series, and that sum is equal to 1 minus next higher term x plus 1 by x plus 2 to the power n plus 1 by 1 minus x plus 1 by x plus 2. 1 minus r to the power n plus 1 by 1 minus r of that type is equal to this x plus 2 to the power n, and from the denominator 1x to the power x plus 2 to the power 1 will be there. So this is equal to x to the power n plus 1 from that, and numerator is x plus 2 to the power n plus 1 minus x plus 1 to the power n plus 1 by x plus 2 to the power n plus 1. They cancel. So it is equal to x plus 2 to the power, rather x plus 2 to the power n plus 1, it is equal to 2 plus x to the power n plus 1 minus 1 plus x to the power n plus 1. Now its coefficient of x to the power 20. So second term will contain x to the power 1. Third term will contain x square. Fourth term will contain x to the power 3 and so on. So its 21st term will contain x to the power 20 from there. So a coefficient of x to the power 20 is equal to, from there, this minus that. So it is equal to n plus 1 C20 into 2 to the power n plus 1 minus 20. Its 21st term. It is equal to n plus 1 C20 2 to the power this minus that into x to the power 20 minus coefficient of x to the power 20 from there, it is equal to n plus 1 C20 into 1. 1 to the power something is 1. So actually this is answer. So we can simplify it, n plus 1 C20 into 2 to the power n minus 19 minus 1, and this is answer. Oh, option is not given. Anyway, this is one of the option. Just 1 minute. Yes, answer is that. So this is our answer, and there are 4 options are there. I forgot to write it. So next problem now. The value of a minus nc1 a minus 1 plus nc2 a minus 2 minus nc3 a minus 3 up to minus 1 to the power n ncn into a minus n. The simplest value of that. Options are there. 2a, na, a minus 1 whole square, 0. There are 4 options. Actually, we can arrange the series into sum of 2 series. Number 1, taking first term a minus a into nc1 plus a into nc2, then minus a into nc3 plus 1 into nc1 plus then minus 2 into nc2 plus 3 into nc3 and so on. From upper line, we can take a common and it is equal to 1 means nc0 minus nc1 plus nc2 minus nc3 and so on. And second line is intact, this one, 1 into nc1 minus 2 into nc2 plus 3 into nc3 and so on. Last class, we have seen that 1 plus x to the power n, it is equal to C0 means 1, then plus nc1 into x to the power 1 means x plus 2 plus nc2 into x square. That's the right last term. Last term means ncn x to the power n. Putting, this is a formula, that is identity. So we can put a particular value of x on both sides. Putting now x is equal to 1, we get 1, I am writing the right hand side, 1 plus nc1 plus nc2 up to ncn. It is equal to 1 plus 1 to the power n, that is 2 to the power n, is equal to that. Let it be 1. And this is our result. This is not our result. Now put x is equal to minus 1 over there. We get 1 minus nc1 plus nc2 minus nc3 and so on. This is equal to 1 minus 1 to the power n, that is 0. This is say 2. So this result, coefficient of a, it is 1 minus nc1 plus nc2 minus nc3. This is equal to 0. Next, differentiate this result on both sides. This one is n into 1 plus x to the power n minus 1 is equal to, this is 0. I am differentiating with respect to x, so it is equal to nc1 into 1. This term will be 2x into that plus 2 nc2 into x plus next term will be 3 nc3 into x square and so on. We have to find here, now put x is equal to 0 on both sides. X is equal to 0 on both sides. Sorry, x is equal to minus 1 on both sides. This becomes 0. And that becomes nc1 minus 2 into nc2 plus 3 into nc3 minus, this is equal to 0. So our simplified result of the given expression is this plus that. Just now from 2 I got this is equal to 0. This is 0. And from there nc1 minus 2 nc2 plus 3 nc3 etc. This is also equal to 0. So our result is 0 plus 0, that is 0. So 0 is the answer. Our next problem. If 1 plus x to the power n is equal to c0 plus c1x plus c2x square up to cnx to the power n, then the value of 2c0 plus 5c1 plus 7c2 is equal to, putting, just like last problem, putting x is equal to 1, this series become, I'm writing right hand side first, C0 plus C1 plus C2 up to Cn is equal to 2 to the power n. Why 2 to the power n? 1 plus 1 to the power n, 2 to the power n. Let it be 1. Now differentiate both sides with respect to x. The right hand side become, this is 0 because it is constant, C1 plus C1 into 1 plus 2 C2 into x plus 3 C3 into x square and up to n Cn into x to the power n minus 1. That will be equal to derivative of this n 1 plus x to the power n minus 1. Again put x is equal to 1 over there. This become C1 plus 2C2 plus 3C3 up to NCN is equal to n into 1 plus 1, that is 2 to the power n minus 1. One thing I forgot to mention, this C0, C1, C2, etc. CR is equivalent to NCR. So we get that. After differentiating with respect to x, we get that. So putting x, so we have to find result of how much? What is the result? 2C0. This C0, oh, not that, 5. Now let it be 2. Multiply. Now we add 1 plus 2 times second equation. This is C0 plus C0 and there is no C0. Now C1 plus 2 times that, 3, oh, result is not that. Now multiply this by 2. So C1 and there is 2C1, that 3C1 plus C2 plus 4C2, that is 5C2, then 7C3, etc. That will be equal to this plus 2 times that, 2 to the power n plus n into another 2 to the power n is equal to 2 n plus 1 2 to the power n. This is our answer. But in the problem, actually the problem I have given, this is not correct. We have to find the value of this. So to find, please rectify it. We have to find the value of C0 plus 3C1 plus 5C2, etc. Find the value of that, and this answer is this. Next, find the sum of 21C6 16 plus sigma I is equal to 1 to 4, 20 plus I, C, 5 plus I. This summation is over I. There are 4 terms here. So we have to find the simplest value of that. Options are 20C6, 21C7, 25C9, 25C8. These are the options. Now, first term, the terms are 21C16 plus. Putting I is equal to 1, this is 21C6 plus. Then I is equal to 2, next third term, 22C7 plus 23C8 plus I is equal to 4, last term. So 24C9. So altogether there are 1, 2, 3, 4 and 5 terms, and we have to find out their sum. Clearly we know that NCR is equal to NC n minus R. This is a property of binomial coefficient. So this is equal to 21C, 21 minus 16 is 5, plus 21C6 plus 22C7 plus 22 and so on up to this. Now they together, there is another formula, NCR plus NCR plus 1. Both are n, and here two consecutive integers. It is equal to n plus 1, C, the greater one, R plus 1. So they together 21, 21, and this is 5 and 6. It is equal to 22 C6 plus 22 C7 plus 20. Now I add these two, this and that. This is 23 C7, 23 C7. Then 23 C8 is there. 23 C7 plus 23 C8 is 24 C8. Now I have added up to this. Next term is 20. So this plus that 24 C8 plus 24 C9. Their sum is 25 C9. So answer is C. Option C. This. Thank you. I request you, if the video helps you, then please share it, like it, and subscribe it if not yet subscribed. Thank you.